Hello, everyone. Welcome to Next Big Future. And I'm going to speak today about the chip shortages for car chips and how that's likely to go longer than most people are expecting. Most people expect it to mostly resolve in 2022, and it'll likely go to 2024 and possibly longer, depending upon how we view the shortage, the constraints of it. And then also I'll discuss why Tesla is mostly immune, is becoming immune to the chip shortage. So the chip shortage going into 2024 and Tesla's advantage. So there have been major chip problems, and those could continue into 2024. There could be 18 to 30 million fewer cars from 2021 to 2024. Already almost 8 million fewer cars in 2021 and into the early part of 2022. And this is about $500 billion or more in less car revenue. Actually, if it hit the 30 million fewer cars, that would be at $40,000 per car, about $1.2 trillion of financial impact over a few years. And Tesla's flexibility will be able to shield it mostly from the impacts of chip shortages. Another impact is that the supply chain could get worse. The Ukrainian war could last, and Russia and Ukraine are the main makers of neon, which is needed for lasers to make chips. And that could have a substantial impact if we're not able to adapt to that. And then also discuss how my prior video, how a flood of EV iron batteries will also impact this situation. So the chips in 2021, so we could have made 79 million cars. That was what legacy automakers were looking to hit, but they ended up with only 71.4 million cars made in 2021. Ford lost $1.5 billion in earnings. GM lost 1.5 to 2 billion. And in terms of like total lost sales, so that was net income level, total lost revenue was maybe $308 billion. And the expectation is 2022 should be better, but Russia and Ukraine is hitting supply chain, so the improvements that are hoped for may not happen. And this is all the impacts were an 11% shortage in 8% of the semiconductor industry. The auto chips are actually a small part of the overall global chip industry. And then in terms of long-term constraints, if we can only make 80 million cars, maybe we should have been making 100 to 110 million cars. If you go back to 2017, 2018, we're looking at 90, 95 million cars per year. So we're already down substantially from those higher levels of car production and purchases. And then there's various forecasts that analog chips could be very constrained through 2024. And I'll go over in more details the different kinds of chips and how this is all working together. So chip shortage so far, an automotive semiconductor demand forecast talked about just short of 12% year-over-year growth in 2021. But with this increased demand for chips, this could go to 18% or more. And there have been, beside the COVID issues, earthquakes in Japan, snowstorms in Texas, a fire at the Renesas, one of the major chip makers facility in Japan, and severe drought in Taiwan that have all impacted chips. And there was another earthquake in Japan, March 16th. So that's also impacting the chip production factories. So the rough estimate of how these chip constraints are, lost 7.7 million cars in 2021. Maybe we'll lose 5.7 in 2022, could lose 3 million cars in 2023. But again, the underperformance could be even worse because things may not play out the way people expect. Also, it's looking at how you're saying short from where. Like if everyone's already forecasting lower sales, then we without any constraints we could have been shooting for 100 million cars, which wouldn't be not that much higher than 2017, 2018, 2019. So a properly functioning world economy should certainly have headed to 100, 110 million cars. There's also more chips needed for certain EVs, and that's also something that's impacting things, where the number of chips going to cars has been increasing for many of the car makers. An exception to that for several aspects is for Tesla, and this I'll go briefly Tesla's immunity. So they've been able to write, Tesla more programmers, they were to write new software to onboard new suppliers, because up to 20 different suppliers for the various kinds of chips, auto chips, and Tesla was able to bring in multiple sources for the chips. So some people had supply and able to write the firmware to bring those in. Tesla also switched to newer chips that are not as in short supply. They're able to redesign. And this is relatively unique to Tesla because they can make 20 changes per week on their production lines in their factories. Others take months or years to make these kind of changes. Ford has been sole sourcing from Renesas for many years. And when Renesas has a problem, Ford cannot adapt and switch out their chips. Tesla also has long-term design to use fewer chips or to use chips that are more in a more efficient way. The Model S from several years ago had 80 MCU chips and the newest version only has 20. They had to make a new network bus inside the car in order to achieve this kind of new architecture. And I said other car makers just doubled the chips they need from cars. So the others don't seem to have the long-term planning or the flexibility to adapt to the changing situation. Infineon is one of the major players in auto chips, and they see chip shortage lasting until 2023. So, their CEO made that kind of statement. Toyota has already in 2022 reduced their worldwide output by 150,000 units in 1 month in February to about 700,000 units, so down 20% in 1 month. Various companies are making new factories, but the new fabs, semiconductor fabs, take 2 years to complete. NXP is the number 2 player in auto chips, and they also see a shortage until 2023. They're working with Ford on the Ford Mustang Mach-E EVs, and they're running their factories full out, and they've invested around $4 billion in prepayments to lock in extra production with fabs, because they do design and work, but they don't own their own fabs for the most part for NXP. Infineon in their annual report goes over who the top companies are for the different kinds of chips. So there's microcontroller chips, Renesas is number 1 there, NXP is number 2, Infineon is number 3, and then Texas Instruments is number 4, Microchip is number 5. For sensors, Bosch is number 1, Infineon number 2. So there's all these different players in these different areas of chips. So, but the overall auto semiconductor area, Infineon is number 1, NXP is number 2, Renesas is number 3, Texas Instruments number 4, ST Micro number 5. So the auto chips are predominantly old chips. So they're from fabs that are 10 to 30 years old. So 8-inch wafers, 200 millimeters. So not the advanced Intel, Taiwan Semiconductor, Samsung chips. So Intel, Samsung, Hynix, etc. They're the biggest overall semiconductor suppliers, as can be seen in this other chart over here. But they are not big players in the auto chip area, because the auto chips are mostly old chips. And I'll go over that in more detail in another chart discussing where the chips are. Only AI chips for self-driving, for LiDAR chips, those are the ones that need the newer, more advanced chips, or have been built on those systems. The microcontrollers, the MCUs, they were the main bottleneck in 2021, and analog chips are likely to be the main constraint going forward, just from analysis by IHS Markit. So the demand for analog chips is increasing much faster than for the microcontrollers. And the need for electric motors, for LED lamps, displays, radar transceivers, etc. As I said, it's a shortage of cheap, decades-old chips. So the odd chip crunch on mature chips, as can be seen here, like from the 1995, the 300 nanometer chips, there's MEM sensors that are 10 per car, magnetic sensors, power discrete for electric cars, chassis, powertrains, analog for power management, etc. So those go from 65 nanometer to 300 nanometer, which is factories that are from 15 years old to 30 years old or more. And then the newer chips only for autonomous driving, memory for the infotainment systems. So they were able to make 95 million cars in 2017, but not only 71 whatever million cars in 2021. It's because they've been doubling the number of chips in the cars. So they've been not properly planning these things and not working with the suppliers to establish the long-term supply. Infineon is making new power chips. So they're making a new factory in Malaysia. But again, these things take a couple of years. The first wafers don't come off the line until 2024, even though they're investing 2 billion euros now for these chips. And they'll be using new materials, silicon carbide and gallium nitride, which are faster and better for this application. And then again, if you think that report goes over in more detail, all the different kinds of chips used that they make and that are used for different aspects in cars, powertrain, electric, safety, driver assist, the various comfort features like moving your seat electronically, infotainment, etc. And so they just again describe how they're the best in class of their chips and various aspects of their microcontrollers. So about every second inverter for a plug-in hybrid or a battery electric vehicle is from with Infineon Power Semiconductors. So they're working with Volkswagen, Neo, Mini, Cadillac, etc. So about close to 7 million of those vehicles, plug-in hybrid and battery electric in 2021 were using Infineon chips. And here's the revenue, about $13 billion per year. Car chips, the overall car chip industry could triple by 2025. It's currently only about 8% of the market. The overall chip industry, of course, still growing. And then these forecasts are just based on assumptions about automotive and being relatively flat, but then more chips being needed and costs of them going up. So you have processors, analog chips, discrete power sensors, memory being the main kind of chips. In the car, you have 1,000 to 3,000 chips in a car, maybe 3,500 chips in a car. All these microcontrollers all over it. And then a coffee machine has 10 chips, a smartphone has 160. So see how chips are fundamental to most of the products that we have. And then most of them are made all over the world. This is from an Accenture report, how they have supply chains globally making these the chips. And then foundries, equipment makers, a vast network of companies that are producing these things. But these companies have been growing faster than the S&P. Again, the automotive area being the low end of the totem pole versus laptops, tablets, gaming, smartphones, 5G, and the AR/VR applications, which are the leading edge of chips, like things for NVIDIA, for graphics, for games, etc. So various growth for these and their, again, the semiconductor chip shortage, how closure to the plants in Malaysia for COVID affected the F-150 production, Toyota's production cut 40% in September, et cetera. So the chips led to reduced cars being made. And then each of the different kinds of chips, logic, memory, analog, optoelectronics, and discrete, and how their segments there, and then who the different players are. It's a complicated web of many companies for different kinds of chips. And that continues for ASICs, et cetera. And then, the revenue, these forecasts could change because, I'm forecasting there'll be far more EVs, which need more chips. The cars can end up becoming smarter than these are forecasting. So they were wrong with these kind of forecasts before. So I have to take these forecasts that they have with a grain of salt as to what will happen, because things are changing rapidly and a lot of stuff going on with war, COVID, other things affecting demand, supply and demand. So other big suppliers in the Falbus area are listed here, NVIDIA, Qualcomm, et cetera. And then the integrated device manufacturers, those are the main guys making the actual chips. And then the increasing costs, the more advanced chips are. So actual investment into these old chip plants is not that much. Now, $4 billion out of, $80 billion, $100 billion for the overall semiconductor industry per year. And the chip companies do not want to make these old plants. So they want to move the automakers to more advanced chips in order to, that they do want to invest in. So again, more list of suppliers. And then again, as mentioned before, only the rare and expensive chips are mainly for the AI, the LiDAR. Tesla doesn't have LiDAR, and they have their own hardware 3 and hardware 4 chips that they designed. They're built by Samsung or Taiwan Semiconductor. Governments, South Korea and the US are looking to support making more semiconductor fabs, et cetera, and part of industrial policy, because they both are also big car makers. So they want to support both industries and are looking to support them financially. And then also there's a lot of software with these codes. So just the things are very complicated in terms of chips and software. So again, discussing that Tesla avoids these shortages with speed and design. They've shown foresight and adaptability, get long-term contracts for chips and for other supply chain materials. They can test rapidly. They can fully test their vehicles, which is why they can make 20 changes a week, is because each car down the line, the second car after the first car can be completely different from the one before it, because they can do complete automatic testing and say, like, is everything acceptable? Yes, it is, and they proceed with the change. Even though they may not know the full impact of it, they know that it's not detrimental. And has to redesign electronics to reduce the number of chips, like I said, 80 to 20 microcontrollers in the Model S. And they can design out the old technologies that chip makers do not want to make anymore, or which are in supply problems. They can just design those out quickly. So they can design for future supply certainty and for superior vehicles. So the EV ramp, and previously I discussed it, I just reemphasize that the EV ramp will be a lot faster than most people forecast. The boom in battery supply already started last year with these iron batteries from CATL, and $200 billion have been invested by CATL and the other major China battery makers, so that it could be enough iron batteries for 30 to 50 million cars in 2025. So out of the total 80 million cars, over half could end up being EV by 2025. And so the change that has to happen is happening very fast to the EV players. They have to be able to adapt to a world with a lot of batteries, a lot of demand, the S-curve where people adopt technology generally. Norway already went from 10% to 75% EV in 6 years. So other countries are following along this path. China, the 23%. So, following the S-curve, they should be rapidly getting to 70, 80% EV by 2025. Germany, France, all in the same boat. US a little bit behind, California the lead in the US on this. So there will be this demand explosion, a lot of batteries, and a lot of need to adapt for using the right chips, the chips that are available, and being able to still manage these difficult supply chain issues to get out the new cars that are demanded. New cars will be EVs. So the way to change to a world with abundant batteries and chip strategies will have to be modified to handle this. And again, it seems that Tesla's set up to win for all these conditions of already being adapted to making iron LFPs for most of their cars, and already making the changes to handle the chip situation. And I don't think any car maker can expand to 10 million EVs per year. And even 4 million EVs would be tough for even the fastest of the Chinese car makers. So you can support and follow Next Big Future. Next Big Future on Patreon and Next Big Future on Twitter, and my website, nextbigfuture.com. And if you can like, comment, or subscribe, that'd be very helpful. And I'll be following up with more videos on the boom in iron LFP batteries, more details about it, what it means for models, different car makers, and the impact of abundant batteries for Tesla and other car makers, and how this shakes out over the next few years. So I look forward to seeing you again for my next video, and thanks for listening.